Assalamualaikum warahmatullahi wabarakatuh. Uh, Last time we reached the how to calculate what you call it example of the problem. So we reach up to here. So we will finish. We'll start with this one. But before we continue, let's go back to the exam more detail on the calculation. So this is the rate that you can get from the saccharose pump, which is barrel per D. It depends on the plunger area, of course. If you have a plunger, you have the area there, and the length of the plunger, it is stroke length, and then how many stroke per minute, SPM, this is N, and then 0.1484 is conversion from barrel per day to inch per stroke, inch cube per second. Okay, so due to what you call it, mechanism of the pump, so the effective plunger stroke is only 80%. So from this equation with this K definition, so we end up with V equal to 0.8 K SPN. K is this value, and SP is stroke, the length of the barrel, and then N is a stroke length. And then we talk about rod strain. Remember that the rod itself is the top of the rod is the larger one, and then smaller, and smaller. So if you see the polished rod load, okay, it is pound force, and the maximum when the rod is going down. So remember that during the going down, you will have the what you call it, lengthen the what you call it, the rod. Okay, so and the rod, the composition of the rod, the largest one is in the top and the small one in the bottom. So if they say that the rod number 86 mean the topmost one is 8 over 8 1/8 of the 1/8 of the inch. So 1/8 of the inch. Okay, so and the second one, if it's 6, mean 1/6 of the inch. So means that 8 over 8 inch, 7 over 8 inch, and 6 divided by 8 inch. So this is the way they make it. So the largest one is 8, 7, and 6. 8 over 8 inch, 7 over 8 inch is equal to. And this composition here, there is a rod table. So rod table, you can see here in the rod table, this rod table. I will give you more clearer than this one. Actually, this one is not very clear. So you can see that if you say 86, 76, 76 means 7 and 6. If you have let's say you have 86, 8 and 6, and etc. So I will give you more detail of this one. And okay, so we will have this percentage in pound force. So let's go there to get more detail on this one. So you can see here the first, okay, the plunger diameter, okay, and then rod weight, total rod weight, the elasticity of the rod. So frequency factor, we don't use this. We use this one. Okay. What is the percentage of each of the rods? So if you say that I want to use 64 with what you call it with 64 with the weight of let's say 1275, so means that you have the 42.3% is 6/8 of the rod, okay, 64,175, okay, 64,1275, okay. So 60 and then 40% is 5/8, and 17.3% of the rod length is 4/8, okay. And then each of the rod weight, as you can see here, for this 6, you can see 6, this is the weight of the 6, 1.634. For the fourth, fifth, 5/8 is 1.134. For the 4 is 0.726. Okay, so that's we have a table from. So this table is coming from. So 30%. So if we want to calculate the weight, is we do it later. And then maximum stress is tau max is PPR, as we already mentioned it. PPR is this number, and then for the minimum we have the MPRL divided by the area of the rod, okay. So MPRL, where it occurs when the rod it moves up. So this is the equation between tau max and tau min. T is tensile, SF is active factor, we already mentioned that yesterday. So this is the suffix factor. So the tensile, minimum tensile strength is this number. Okay, so if we plug in this everything here to this equation, so equation of 5, 6, 6 or 5 and 7 to number 8, we have equation 9. Equation 9 is a PPRL and etc. is coming from these 3 equations. Let's also talk about the acceleration. So Nin explained that when the plunger moves down and then close to the bottom point, that's where the acceleration is maximum when going down. So it explained that is additional load that close to bottom. So this is the expression that given by name. this is if it's plus crank crank divided by fitment. If it's plus is for conventional, negative for Mark II. And then need also explain the maximum acceleration and the upstroke is close to top stroke. Okay, so again this is the expression, and negative in this case, negative is conventional, and then positive for Mark II. So whatever is mentioned first is conventional, and then mentioned the second is Mark II. And then the PPRL is the liquid column, the weight of liquid column, the weight of plunger, the weight of rod, the load of acceleration, load friction, and then plunger moving out because of the PWF or P3. So this is the load to the load from top to bottom. This is the force from bottom to the top. Okay, so this is due to PWF, or we call it P3. So we ignore the plunger rod, and then so with P3, PWF is pump intake pressure. So if we eliminate everything here, so we have a fluid column, a rod column, because we ignore the plunger, and then load because of acceleration, and then the force to the upper part. So we ignore the friction, and then this one is so we ignore the plunger weight, we ignore the friction, we end up with having 1, 2 acceleration, and this force from bottom to the top. Okay, up to here we will continue later on.